Now this is the water and ice experiment number 2, but please, before you watch this, make sure that you've watched the water and ice experiment video number 1 and that you've carried out that experiment. Otherwise this is going to rather spoil the fun for you. Now you'll remember the first part of that other experiment was to mix water, which in my case was at 50 degrees Celsius, with cold water, which was at 9 degrees Celsius, and I wouldn't tell you at the time what the resulting mixture temperature was. Well, I can now tell you it was actually 27 degrees. And then I asked you to see if it was nearer to the hot water, or if it was nearer to the cold water, or if it was somewhere in the middle. Now, if you look at the thermometer, you'll see that 9 degrees is here, 50 degrees is here, and 27 degrees is just here. So it is almost exactly in the middle. So that worked out pretty well. Now let's have a look at the ice situation. Remember, I wouldn't tell you these either, but if we have a look now, I've put the thermometer back in the ice. It's been there a few minutes. If I pull it out, I hope you can see that. It's just about 0 degrees Celsius. It's going up now, of course, because it's in the nice warm kitchen air. But it was about 0 degrees, or perhaps slightly lower. Now I'll put that thermometer back into the mixture of ice and water, and I'm going to leave it there for a couple of minutes so that it can adjust to the temperature. Now let's have a look, and we'll have to be quick. It's about 2 degrees Celsius, only just above the freezing. Now you should have pretty similar results. Your ice should have been at about 0 degrees, perhaps slightly colder if it's come straight out of the freezer. When you have the mixture, if you have any ice left at all, as we have here, then the mixture temperature should be about 0 or just above 1 or 2 degrees perhaps. Now, why is it so different with the water to the ice? Well, the reason is that to melt ice needs an enormous amount of heat. Where can it get the heat from? Well, it can only get it from the hot water. So the first thing that happens is the water cools as the heat from the water goes into the ice and starts to melt it. And more of that heat comes from the water into the ice until they're the same temperature, or near enough. Then no more heat can go from the water into the ice, so what's left of the ice stays as ice, and the water has gone right down to the same temperature of the ice, which is about 0. Completely different to the water situation. Now in a moment I'm going to show you another experiment that you can do with ice. It's good fun, isn't it? Now in this experiment you will need to be able to time 5-minute intervals, so you will need some sort of clock. A kitchen clock, a mantelpiece clock, a stopwatch, doesn't matter at all. I'm going to use our beautiful kitchen clock here. Now in this bowl I have about 400 grams of hot water. It's actually at 44 degrees at the moment. Now I'd like you to set up the same situation, so you have about 400 grams, it doesn't matter exactly in this experiment, and you measure the temperature in Celsius of course, and write it down please. Then wait 5 minutes and see what the temperature is then. And of course it should have cooled a little bit, so write that down too. Then wait another 5 minutes and write that down as well. So at the end of 10 minutes you'll have 3 readings: the temperature at the beginning, the temperature after 5 minutes, and the temperature after 10 minutes. So you'll see how quickly the temperature is going down. And then this is where the fun starts. Here I have 4 glasses, and in each glass there's about 50 grams of ice. So when you get to 10 minutes, in goes the first lot of ice. Stir it up. You can take your time doing this, because we're not going to read the temperature again until 15 minutes. Now, as usual, I'm not going to show you my answer because I want you to do this for yourself. Keep stirring until all the ice is gone. Wait until the clock shows 15 minutes has passed, and then read the temperature. Then wait another 5 minutes and read the temperature again, and then in goes the next lot of ice, and do the same again. Stir it up, wait 5 minutes and read the temperature again. So what you're doing is you're reading the temperature every 5 minutes, and you're putting in about 50 grams of ice every 10 minutes. And then I want you to look at your results and see if you can see any patterns. What happens when you don't put the ice in, and what happens when you do put the ice in. You have to look very carefully at your results. This time I'm not going to tell you the answers. It's for you to decide.